So Unit 4 is going to cover properties of sections. Unit 4.1 is going to cover centroids. You need to know how to find a centroid, which is the point on a cross-section of a solid object that is at the same point of the center of mass of that solid object. Finding the centroid will allow you to find the location of what is called the neutral axis or the neutral plane. Is it about this neutral plane that if you have a force on a beam, the fibers above this planar axis will be in compression, and then the fibers below that plane will be in tension. And then knowing that, you can design around it. So, like I said, this is Unit 4.1 Centroids. So when you go that, I have the assignment up on Canvas. You'll work through. We'll work through the example together here in this video, and then it'll be up to you to actually put together another Excel file with all the math on the problems towards the bottom of the text provided. So I'm going to jump over to an Excel file and a little bit of some sketches here. So in order to find the centroids, you can break each shape down into some simple shapes, such as a rectangle. So here I have the equations of finding a centroid for a rectangle, which are pretty simple. You have your B, which is your width, and your D, which is your depth or height, and then it's just taking those numbers and dividing them by 2. That'll give you your X and Y of that centroid. So that's pretty basic. Same thing with a circle. You just take the diameter divided by 2, and that's your centroid, the radius of it, basically. And then a triangle is going to be your depth or your width divided by 3. And that'll give you, once again, give you your X and Y of that shape. So here is the shape from the example. So you can break this down any way you want, but this is how I broke it down. I have 3 rectangles and 2 triangles, and then I placed my XY about this corner here, which is the intersection of these 2 lines. So my first shape, which is right here, I'm going to label that number. Let's see here. This is shape 1, shape 2, 3, 4, and 5. So now that I've defined my simple shapes, I'm now going to find the centroid for each of those shapes about this determined axis. If I had placed the axis in the middle here, that's where I need to measure from going forward, but I placed it here, so everything is going to measure from this corner. Finding the area is simple enough as just taking your base time height, which you all should know, and then the centroid is going to be so for rectangles, that's base divided by 2, but we also have to take into account the distance from the axis that we determined previously. So for the X there, that's easy enough. In the X direction from the Y axis, the centroid would be at 3, or if I wanted to use Excel, 6 divided by 2. And then the Y is going to be 0.5 if you're just taking into account the actual shape, 1 divided by 2, but then it's 7 inches from the X-axis there. So I'm just going to type 7. Once again, area, base times width, your X, so in the X direction, in the X direction from Y, it's going to be 3 again, and up we have 8 minus 2, so that's going to be 3 plus 1, so 4. So that should be simple enough to follow, but if you didn't, this shape is 6 inches tall. Cut that in half, that's 3 from here to here, and that's 1 inch there, so that gives me 4. The next shape is the bottom rectangle here, so once again, area 2 times 1. Your X is also still 3, and your y now is just 1 divided by 2.5. Okay, so for the triangles, that's going to be your base divided by 3 and depth divided by 3, or height. And the area of the triangle is equal to your base times depth divided by 2. And then your centroid is going to be your base divided by 3. But that's going to give you the distance from, say, this edge here to the centroid. So that's this edge from the y is 2.5 because we have 3, and that's 1.5, blah, blah, blah. So we're going to take that minus 2.5. And I did that wrong. My bad. I wanted 2.5 minus this. There we go. And our y is going to be, once again, our depth divided by 3. And I hit enter too quickly. And then I want to add in this 1 because that's the distance from here up plus 1. Do plus 1 there. Similar thing here. We're going to do our base times depth divided by 2 for our area. The same. And then we have, in this case, we do 3.5 plus that. So 3.5 plus our, I don't need parentheses, plus base divided by 3. Why is that not working? Oh, because I didn't press equals. Equals plus base divided by 3. And then the same thing from the last one, our depth divided by 3 plus 1. So now we're going to take the sum of the moments of the planes in the x direction and the sum of the moments of the planes plane areas in the y direction. So we're going to take, and the moment is just going to be area times the centroid. So we'll take, let's do a sum, and we're going to take area times x, comma, area times x, comma. You can add, just do plus on this if you don't want to use the sum function. And area times x, comma, area times x, and then I got one more. Area times x. And then we'll do the same thing for the y. Let me just see if this is a faster way of handling this. We got our y's on there, now we just have to replace it with the area. Double click. Nope, wrong one. Click. And there we go. And I'll do the sum of my areas. Holding down Control. So the moment of the entire area equals the sum of the area times the centroid location. Since we know the sum of the entire area, or sum of the entire area and the moment of the entire area, we can now solve for the centroid of the area. So if, let's write this over here. So if m equals a times c, and we know a and m, we can divide by a. So the total moments over the total area will equal the centroid in the x and y. So I will take, let's see here, I wanted to take my m divided by area, which that works out. That one makes perfect sense because in the x direction your centroid would be 3 inches from y. And then this one here, and then for the centroid in my y, I'm going to do my this divided by, wrong one. I'm going to do my moments in the y divided by a, which came out correct, but I actually already fixed this. Some of you may have noticed that when I was going through this that I typed 7 here, which would give you this number, but it actually should be 7.5 because half of 1 is 0.5 up. Yeah, so that was a mistake, and I just fixed it. So no longer a mistake. This is the right answer. The problems are not nearly as complex as this shape, so this should be plenty of information to actually get each of the shapes shown in the problems completed.